Hey, good morning, everyone. Good morning.
Good
Good
morning.
morning.
Hey, good morning, Nicole.
Good morning,
Good
Professor.
morning, Noel. Good morning. Um, how's everybody else? Naomi and Kara Liz. Let's see. It looks like we have 7 people currently in the collaborate. Alrighty, why? My connection is poor. Could be. And let me check how many are in today's forum, right? Um, so it looks like I have 8 people, 8. So, and we have 8, 7, only 7. So one more person, right? One more person still needs to join, but whoever it is, hopefully will join very shortly. Now, so let me share my screen. So today, so we took care of everything about future value of annuity last time. So we're now moving on to the present value of annuities. And okay. So of course you need to open this Excel file. Now, if there is a future value of annuities, of course, then there should be a present value of annuities. Why? Annuities are anyway, if you think about it, annuities are all in the future, right? Regardless, isn't that right? You're receiving payments or making payments from today at time 0 or from time 1. In ordinary annuity, it is time 1. You start, right, making a payment or receiving payment at time 1. All the payments are basically cash flow in the future, right? All the payments are cash flow in the future. So look, in future value of annuities, right? Well, still, all the cash flows are in the future. And what you want to know is what's the sum of all those, all those cash flows at the maturity, right? In present value of annuities, uh, we just want to we just flip our switch our or flip our end and want to know the present value of all those future cash flows, right? So this is something that a lot of students confuse because payments are in the future all the time. Cash flows are in the future. Of course, cash flows are supposed to be in the future because past cash flows don't mean anything to us because it doesn't. Because always, um, what is important to us is either the present value or the future value. There's no past value because past value doesn't. It's already past. It's history. Doesn't it doesn't do anything to us. It doesn't give us anything. It's done. Uh, so cash flows are in annuities. Cash flows are all in the future, and because of that, students often think they cannot distinguish between future value of annuity and present value of annuities. But it's logical thinking. And those who are not trained for logical thinking cannot hold on to the logic, cannot get the logic, and then they simply break down there. The question will be either the wording of the question will be either uh, how much will how much will you have, or in 5 years, or how much will there be in 5 years, or what's going to be, how much is going to be in how much is going to be worth in 5 years. I mean, the wording is already in the future tense, right? And then if it is present value of annuities, what is it worth today, or how much do you need to have today, or how much do you need to invest today? The wording is in the present tense, and some students cannot just get it. There's simply lack of thinking. You don't have to, but everything you learn in school is supposed to help, supposed to train and foster your ability to think. But the sad thing is, a lot of, in the U.S. public school system doesn't enforce that. And enforcing anything is people, violently revolt against, enforcement of anything. Then they say, my choice, my choice. And then it's also your choice to become stupid, or and they call it, you need some type of rigorous thinking framework, and that needs to be fostered through your K through 12. But a lot of people don't get that rigorous thinking frame, thought frame, rigorous thought frame. And it is only fostered through math, because K through 12, in K through 12, what kind of class that you learn teaches you how to think rigorously. There's no rigor in nothing. All the other things that you learn in school, public school system, K through 12, are all, liberal arts, free willing thoughts. They all, it's just, liberal arts. Of course, there are some students, there are physics, science, of course, physics, chemistry, biology. I mean, science courses, earth science, at least they try to, these are aimed at fostering this rigorous thinking. But then in, K through 12, in that period, or on that level, nothing rigorous is enforced. Mental rigor is never rigorous. Mental rigor is never enforced. And then they just, celebrate, just celebrate your, celebrate your being, your personality, celebrate this, celebrate. Everything's all like, hippies. And even they, even writing writing with rigorous writing with rigorous rules. That isn't even enforced. And then only thing they learn through K through 12 is my body, my choice, regardless of whether what you do has impact on other people. So that is the problem of the public education system. It's just nothing but a revolving door. You just go through that. Just just go into a revolving door, just automatically come out of it without any training for rigorous thinking. So the point is, then the students, even when they are 20, 21, I mean, legal drinking age, 21, then you are considered adult. If you can legally drink, you're considered adult. But being an adult, but still with the mind and intellect of just nothing but 16-year-old or 15-year-old or 14-year-old, because there was no training of any rigorous thinking. So they read without any comprehension. They read. They can read, but there's no comprehension. In simple sentences, everyone without any sentence mark, without any period, just like text message. It's a simple statement, but not a complete sentence. Hardly anyone can compose a complete sentence. Everything is incomplete. That's the outcome of the public education system in the U.S. So I'm very, I know I'm very critical of the public education system. Another, but I don't want to dwell too much on that. But the reason I'm being very upset about the public education system is after going through all those revolving doors, they come to college and they are not prepared. When they get to college, they are not prepared for the college level courses, and they're not prepared for the college level rigorous, thinking framework. And for even the, but of course, then through training, through training, you're supposed to get better through training. But there is absolutely no lack of physical time for that training. I mean, if we are given like twice the time, 90 hours per semester, but we have only 45 hours per semester, and there is absolutely no way um, we can have sufficient training for this type of brain work. And that's something that uh, I'm so disappointed about. Anyway, so here's the example of present value of annuities. So you see, uh, you're making $5,000 deposit or payment at the end of every year for the next 5 years, right? And of course, these cash flows are all at the end of each period, right? So it's ordinary annuity. And our question is then, what is it? What's the present value of all those annuities today? So what is it worth today? Hmm? Why do we want to know? I'll get to that. Why do we want to know? What's the present value? Uh, why do we want to know the present value of all those future cash flows? Uh, but the idea is simple. Um, if these cash flows are occurring in the future, we need to discount it back to present, 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 present. And if, of course, we know how to discount it, and then, sum of all of that is the present value of annuities. Now, um, in this example, this diagram, this is annuity due because the payments are made at the beginning of each year, right? Um, then we find a present value. First of all, this one doesn't. The first deposit, first payment doesn't need to get discounted because it's already present value. But then if you do, we know what it is because we discount it by 1.05 the interest rate, the discount rate raised to zero. Anything raised to zero is one, so it becomes just itself 1,000, and then discount, and you can also see the difference between the two. Difference between the two. The difference is that uh, annuities due have one less compounding, one less compounding. I mean, one less discounting, one less discounting, right? You see, the discounting happens, 5 times for this one, 4 times, right? And even the first payment is discounted once, right? Uh, but here, the first payment is not discounted. The second one gets discounted once. The last one gets discounted only 4 times, not 5 times. So there is one less discounting for uh, ordinary annuity due. Remember, there was one more compounding, right, for annuity due in case of a future value of annuity, and in case of present value of annuity, one less discounting. But one less discounting is the same thing as one more compounding. One less discounting is the same thing as one more compounding because they cancel. They cancel one. They cancel. Uh, in other words, what is it? What I'm talking about, um, you should all recognize this. And whiteboard. Let me. So we all know. You all know. X to the negative 2, x raised to negative 2. What is this? Anyone? x raised to negative 2. What is this? Can anyone tell me? No one? I don't want to switch screen here because it's going to be, oh, at least I will, I can see who's, anyone there? Angelica, are you there, Angelica? Brandon, are you there? Yeah, hi, Angelica.
Hi.
Angelica, yeah, hi. Can you answer this question? What is x raised to negative 2? Hmm? X raised to negative 2. You forgot already? Brandon, are you there, Brandon? Fahad, are you there, Fahad?
I
Fahad?
don't know.
Oh, you don't know? Okay, but you're there. Good. Jeremiah, are you there, Jeremiah? Jeremiah. Kiara Liz, are you there, Kiara Liz? Kiara
Yeah, I'm
Liz?
here.
Yeah, hi, Kiara Liz. So can you answer this question? What is x raised to negative 2?
I don't remember the formula.
Oh, no, it's not the formula. It doesn't, I mean, there is no formula. I mean, it's just notation, right? Uh, Naomi, are you there, Naomi? Naomi, okay, Nicole, are you there, Nicole?
Yeah, I'm
Nicole,
here. Hi.
okay, hi. Yeah,
Would
Nicole,
it
you have the.
would it
Mhm.
sorry, would it be 1/x²?
You're right, Nicole. You got so
Thank
Nicole, mhm, you got 0.25. Yes, the first person to give me the correct answer today, this morning. Yes, it is 1 over x squared. That's, right? The reciprocal of the exponent, right? The reciprocal, or negative exponent. Negative exponent is always the reciprocal. And then, think about it. Suppose you are multiplying, suppose you multiply x, then what does it become? So, Nikari, are you there, Nikari? Nikari? Yeah, it looks like you're there because your microphone is on. Your mic is on. But I think you need to unmute. Noel, are you there, Noel? Noel?
Yeah, I'm here. Can you hear me?
Yeah, I can hear you, Noel. So can you answer me? If you multiply x to this, what does it become? If you do that, uh, what does it become?
Would it be 1 over x to the third?
Yes. Say that again.
1 over x to the third?
No, you're multiplying. It will become 1 over x. It will just become 1 over x. Right? Why? Because it's like it cancels. This cancels out with 1. In other words, what is 1 over x squared? It's x times x. 1 over x times x. Isn't that right? Then you multiply x to that. Multiply x. Then it's like this. Then what should happen? 1 must, x and x must cancel out. And it becomes this. Right? Just think about it. 1 over 4 times 2. Which is, 1 over 2 squared times 2, right? And then what is that? 1 over 2 times 2 times 2, right? I mean, it should cancel out like this. So it should become 2 anyway. Multiplying something to a fraction, it gets multiplied only to the numerator, right? Just do a simple. Don't try to find, what's the formula for this. No, just use logic. Just use logic, and the logic can be you can deduce the logic simply by plugging in a couple of few numbers. Isn't anyway that's 2 over 4. Isn't that exactly 1 over 2? Right? And then, so this is, think of it like 1 over 1 plus r squared. If x is r squared, right? Or all to the third, 1 plus r cubed, and say you are multiplying it by 1 plus r. So that's one more compounding, but then one more compounding will bring this down to 1 plus r squared. So this becomes 1 less discounting. Isn't that right? Does that make sense? Vivian, are you there? Vivian? Vivian?
That makes sense.
Yeah, Brandon, good. Yeah, that makes sense. This is logic. Okay? This is logic, logical thinking, basis for intellect. And that's why I'm saying, that's why I've been telling you, one more compounding is the same thing as one less discounting. Right? Remember why I'm talking about that? Look at the difference. All ordinary annuities have one more compounding, or all of them have one more discounting than annuity due. Annuity due has one less discounting. One less discounting. Right? Look at this. This one is, discount 5 times, discounted 5 times, 4 times, 3 times, 2 times 1. But this, the fifth, this is the 5th payment. Gets discounted only 4 times, 3 times, 2 times. First one isn't discounted at all. Why? So all of the annuity dues have one less discounting than ordinary annuities, which is the same thing as one more compounding. Now then, this way you can memorize it as all annuity dues have one more compounding than ordinary annuity, regardless of future value of annuity or the present value of annuity. Right? So, and again, this is a simplified example, very simplified, because reality isn't like this. So what is the reality like? So let's take a look at the so present value of annuities are very frequently used for um, loans, right? First of all, think about it. If you take out a loan, right? If you take out a loan, no lender, no creditor will wait 30 years for you to come up with the future value, one lump sum future value, right? Um, Suppose you got a um, mortgage loan, and the mortgage is usually the payback, the maturity, the payback time is usually like 10 years, 10 years, 15 years, 20, 25, 30 years. I mean, 15 years would be the lowest, not even 10 years. We can pay back the mortgage in 10 years. But usually, so 15 to 30 years. So you got 30-year mortgage. I have 30-year. I only have about 30-year mortgage. I have about 10 years left, I think. Um, if you have 30-year mortgage, uh, so you bought a house. You you took out a loan for $500,000, and so it's a 30-year mortgage. Will the bank Is there any bank that will wait 30 years for you to come up with a large lump sum future value and to pay back? Huh?
No.
No, it's out of the question. That's out of the question, isn't it right? That's out of the question. So what happens, right from the next month, right? Right from the next month, your payment starts, right? Your payment starts. So basically, it's the question of, you know, ordinary annuity. And why present value? Why is it the present value of ordinary annuities? Look, if you extend this timeline to 30 years, and of course, it's monthly, so there will be 360 of these uh, the grids or time notches, the notches, right? On the timeline, there will be these, notches, or what should I call that? Points, 360 of them. So obviously you can't do it this way because it's going to be it's going to be too tedious. It's not undoable. It's going to be tedious. But why present value of annuity? Because it is present value of annuity because all of those monthly mortgage payments, which are basically annuities, the present value of all of them must be equal to the loan you took out, the principal of the loan you took out. Right? You understand? So it's like, when you take out a loan, right? So it's $500,000, 500K mortgage, right? And over the next 30 years, 360 monthly payments, right? And each payment is comprised of principal and interest. So you are paying interest through these payments, right? So basically, the starting point of all those payments must be the original loan amount. Exactly. Do you get that? Do you understand that? That's why it is a present value of annuity problem. All the loans are basically present value of annuity. That means present value of all those annuities must be equal to, right? your loan principal, right? Otherwise, something's not right. So you can think of it this way. Also, where's my okay, the whiteboard, right? Let's go back to the whiteboard. So then our question is, you have principal, which is the your principal of the loan. There are three possibilities. So our question becomes the question of whether sum of all those present value of annuities, right? Mathematically, sum of all those present values of annuities must be equal. It must be equal to the principal of the loan, right? And that's the only way it can be. That's the only way it should be. But sometimes, by some fluke, principal can be greater, or the present value of the annuities can be greater, right? Of course, this will rarely happen because banks don't make this kind of mistakes. But what if what if it's like this? That means all present value of all those annuities are less than your principal. Well, of course, then that's a good news for you, isn't it right? You're paying less than what you're paying. This is what you pay. Present value of what you're paying. You're paying less than what you owe. Right? Good news for you. But what if it is like this? Well, then that's the bad news for you, isn't it right? You're paying more than the present value of all your payments are greater than your loan principal. So you're paying more than what you owe, right? Of course, in reality, this will rarely happen. But it can, but it can happen. Why? Look, when you got the loan, you locked into some interest rate, right? And then that interest rate is basically supposed to be the discount rate throughout the life of the loan. Isn't that right? But then that's when you sign the loan contract. But over time, it's 30 years long. I mean, even within 5 years, the interest rate fluctuates. Interest changes. The interest rate I'm talking about is the market interest rate. The interest rate on your loan, right? The interest rate that you pay on your loan doesn't fluctuate. It's locked, right? Unless originally you the loan contract was based on flexible interest rate or adjustable interest rate, unless, and usually people lock into a 30-year for the entire loan period, loan term. So that's why they try to get a good rate, right? You want to get lock into a good rate so that regardless of interest rate fluctuation, you lock into something something that you think is lowest possible rate you can get, right? But the market rate changes every once in a while, and then if you use the interest rate on the loan as the discount rate, it will always be equal. They will always have to be equal because the calculation of the monthly payments were based on that. But then if you discount over time, over 5 years, 10 years, 20 years, 30 years, there will be several. Not just several. There can be even over 30 years. There can be a dozen interest rate changes, right? And if the interest rate goes down, what happens? If interest rate goes down, right? If the market interest rate, not the if the interest rate goes down, the present value goes up, right? You should easily understand that. Because the discount rate goes down, right? As the discount rate goes down, because it's the denominator, right? Denominator goes down, the whole fraction goes up. So present value, or it will go down if interest rate goes up, the market interest rate goes up, right? So think about it. If interest rate goes up, market interest rate goes up, the present value of annuities goes down, then you're paying back. And think about it. You're paying back less than what you really owe. And you might, if you're still wondering why, if interest rate goes down, am I not paying more interest? No, you're not. You're paying a fixed rate because the rate on the interest you pay on the loan is fixed. You locked into that when you signed the contract. So for 30 years, it will be held constant. But what goes up or down is the market interest rate, not yours, not the interest rate on your loan. You have to get it in. Then obviously, it becomes relative. I mean, what you're paying as interest is lower than the market interest rate. So obviously, the whole the present value of annuities goes down. That's good news for you, right? Otherwise, if it is like this, it's bad news. But if you use your loan's interest rate as the discount rate, it will always be equal. They will always be equal, right? Then that's what the bank that's what the bank thought used at time zero, right? And the bank just, bank doesn't, uh, uh, bank use, whatever is, in their best interest at the time, right? And you agreed to that, thinking that that was the best available, best possible rate for you at the time. So, well, that's all the time we have for now. We haven't got to the actual example. Um, but any questions so far? Any questions? Anyone? Any questions?
So
Um,
far, so far, it makes sense.
Okay, good. Alrighty. Angelica, you have something to say?
Professor, yes, it does make sense. And I wanted to let you know, I did receive a letter in the mail, like talking about the vaccine and like
Uh-huh.
might be getting withdrawn from the class. And I emailed like my advisor,
Mhm.
and the health department to let them know that I'm going to
Yeah,
receive a second
yeah,
dose
yeah, yeah.
soon.
Yeah. Sure, you should. You
Yeah.
should. Yeah, because you are not technically withdrawn from class until the last day of class. It's just no warning. Because the last time it was just about a week ago. The last time I checked the current roster, nobody got WA. Okay, there
Yeah.
were people that got W's, but those are the people who voluntarily dropped the class. Those are the people, but there was no WA. Okay, so as long as uh, what the letter means is that if you don't submit your proof of vaccination by the last day, then at that time, then no matter what you have got until that point, you will be automatically given WA. So um, as long as you don't have to worry about it as long as you submit the um, proof of vaccination by the last day. Okay. All righty. So, but otherwise, it made perfect sense to you, Angelica, right?
Yes. So
All
I
right.
just want everyone else
Okay.
to email the health department and let them know if you're still waiting on your second dose.
Yeah. Good information. Also, let the registrar know.
Hmm.
Registrar. Okay. All righty. So that's it for today. Have a great afternoon, and I will see you guys uh, next Tuesday. Oh, you all know that the quiz 2 is starting this Friday, right? You all know that, right?
Yes.
Quiz 2.
So tomorrow,
Okay.
Friday?
Yeah, tomorrow, yes.
Okay.
All righty. All righty. I'll see you guys. I'll stop